Let's talk about the invisible stuff, the infrastructure of your daily commute.
Oh, yeah.
You know when you're on a subway car and the whole thing is just rattling and shaking, but you look up at the screen and the arrival time is perfectly steady?
It's one of those things you completely take for granted. You only notice it when it breaks.
Exactly. So today we're doing a deep dive into the actual hardware that keeps that screen alive while everything else is shaking apart.
And this is a fascinating piece of kit.
It is. We're looking at the NTI VOPEX-M12V-8 industrial VGA splitter. And I have to say, the first thing that jumped out at me was the VGA part.
It does feel a little like a blast from the past, doesn't it? Those blue connectors.
I mean, I don't think I've even seen a VGA cable in, what, a decade? Why is this piece of modern heavy-duty tech using a standard from the 80s?
That's the real disconnect, between consumer tech and industrial gear.
Hmm?
Your laptop is basically obsolete in 4 years. But a train car, a factory control system, that equipment is designed to operate for 20, maybe 30 years. So you have this modern engineering problem of adding ruggedness to legacy systems.
So the mission of this little box is to bridge that gap. Take a signal from one computer and blast it out to maybe 16 different monitors.
And do it using standard internet cable like CT5 or CT6, but in an environment that would kill your desktop computer in about 5 minutes.
Okay, so that has to be the M12 part of the name. I was looking at these connectors, and they look nothing like what I have on my computer. They're circular and threaded.
That is the absolute key feature. They call it a positive lock.
A positive lock.
Yeah. Think about it. A normal cable on a train will eventually just vibrate loose. It's inevitable. The M12 connector isn't really a plug. It's more like a bolt. You physically screw it in.
So it basically marries the cable to the box. It can't come loose.
Never. And the rest of the build follows that same philosophy.
It looks like it. It says it's a rugged steel case, powder coat finish. And the power input is weird too. No wall plug. It takes 18 to 36 volts DC.
And that's a huge clue about where it's designed to live. That voltage range is really common in rail systems and industrial grids. You don't need a separate power adapter. You just wire it right into the train's main electrical system.
It also mentions ESD immunity, electrostatic discharge. I'm guessing that's a bit more serious than just a little shock from a doorknob.
A lot more serious,
Yeah.
yeah. In a factory or on a fast-moving train, you build up huge amounts of static. A single spark could instantly fry the circuit board on a normal device.
But this thing is hardened against that.
Exactly. It's built to just shrug it off, meets specific IEC standards for it.
Okay, so it's built like a tank. It's vibration proof.
Right.
But what about the signal? I mean, train stations, factories, they're huge. Does the video actually look good after traveling 600 feet?
Well, that's where physics always asks for a trade-off.
There's always a catch.
There is. The device supports a really crisp resolution, 1920 by 1440, which is great for sharp text on a sign.
Right.
But you only get that top-tier quality at about 100 feet. The spec sheet shows it's a sliding scale.
So if you push it to the maximum range, the full 600 feet, what happens?
The resolution drops to 1024 by 768.
Okay.
But you have to think about the context, right? If you're just displaying a departure time on a platform that's 2 football fields away, 1024 by 768 is perfectly readable.
You're trading pixels for distance.
And for absolute reliability. The goal isn't to show a 4K movie. It's to get vital information from point A to point B every single time without a glitch.
And it's not just video, right? I saw it supports audio, too.
It does, yeah. CD quality stereo, so you can sync up announcements with what's on the screen.
So when you put it all together, this VOPEX box, it's really a reminder that so much of our world just runs on this hidden, kind of unglamorous engineering.
That's it. I'd call it a communication lifeline. We all get excited about the slick screens and the fancy interfaces, but none of that works if the plug wiggles loose or the signal dies halfway there.
This little box just exists to make sure the message gets through.
No matter what.
It really does change how you look at things. So next time you're on a rattling subway car and you glance up at that perfectly smooth, glitch-free arrival screen, just think about those little M12 connectors screwed in tight and that steel box somewhere in a panel just invisibly keeping the pixels flowing. Thanks for diving in with us on this.
My pleasure. It's a good one.